Back here, we got Joe videotaping again. He's doing a great job. We are continuing. We're now on lesson 86. We're continuing the Pythagorean theorem and seeing how we can use it for some application type problems, not just on grids. So we're going to look at that. We're going to develop a formula for it so that we can just plug those numbers in and solve it very, very easily. All right, so we're looking at distance. Now, distance is easy if it's in a straight line, but if distance is at an angle, if we're looking at this, if we're looking at some distance and angle and we can't count or we don't have a measuring device, we can use Pythagorean theorem to figure out what that is. We don't always carry our tape measure around, so when we want to know what this is, maybe after the fact, we can use Pythagorean theorem in order to find that distance. All right, we'll look at example number 1. So the diagram shows a grid of the city's streets. A car travels from point P to point Q by moving east to point R and then south to point Q. What is the direct distance in the city blocks from point P to point Q? All right, so we're looking at our diagram here. We count the blocks over. There's 1, 2, 3, 4 blocks over. Some get confused and start counting at the point. But remember distance. I haven't gone anywhere, so that's really 0. I've gone 1 block, 2 block, 3 block, 4 block. Okay, down here, 1 block, 2 block, 3 block. Okay, we see we have a right triangle there. So we look at this. We're going to use the Pythagorean theorem. Okay, a squared plus b squared equals c squared. Remembering that a and b are the legs. Okay, they're the legs. So we're going to solve this for the hypotenuse. Now, maybe you remember, okay, 3, 4 is a special Pythagorean triple. If you remember that, it's 3, 4, 5. The hypotenuse is 5. So I can save myself some time if I have some of those triples memorized. Another one to remember that's used a lot is 5, 12, 13. So you can memorize those. You'll save yourself the trouble of solving it by Pythagorean theorem. All right, now, what are the legs? Give you a second to think about it. What are the legs? I'm not asking you, Joe. I'm asking the people watching the video. The legs are 4 and 3, the two sides that make up the right angle. Okay, so those are the ones that are going to be grouped together on the left side of the equation. All right, and then the hypotenuse is what we're going to solve for. We'll call it C. We can call it whatever letter we want. Later on we use D for distance, but right now we have C. So we do 4 squared plus 3 squared is equal to C squared. All right, we square those before we add them. 16 plus 9 is 25, and 25, the square root of 25, we all should know, is C. So we get that distance would be, did I say C? I think I did. The square root of 25 is 5, so C is equal to 5. All right, now this is a bunch of just problems that I've worked out before. Skip on by that. All right, okay, now, what we can do is, with Pythagorean theorem, we can develop a formula for distance. Okay, and this is the formula. We'll show you how we get there. All right, if we look at this, okay, if we wanted the distance from P to Q, all right, well, how do we get this distance right there? Well, before in the last example, we just counted the squares. All right, is there another way to do it? Now we look at this. This is the x direction. I've gone from 1 to 5. If I go from 1 to 5, what do I do with those two numbers to figure out the distance? Well, 5 minus 1 is 4. So we subtract the x values to figure out what this is. So x1 minus x2, or x2 minus x1. Really, the order doesn't matter. Well, let's see this. If I did 1 minus 5, I'd get a negative. So it's really the absolute value of those two values subtracted. All right, we look at this. We want the distance here from 5, 4 to 5, 1. Well, the y value is 4, and the y value there is 1. What's the distance apart? Well, I could count it 1, 2, 3, or I could just subtract it like I did the x's. So we get y1 minus y2. Take the absolute value of that will always give me the distance. All right, then we're looking for this. Now, before we labeled it C, a little bit more practically, it's distance, so we use the letter D. All right, now if we set that up, okay, into a formula, we could take this and square it and add it to the difference of the x's squared, and it would equal D squared. Now, to simplify that a little bit, all right, let me go ahead and write this out. So you get D squared is equal to the absolute value of x1 minus x2 squared plus the absolute value of y1 minus y2 squared. Get out of the way so you can see that. Take a moment if you're taking notes with that. All right, now if I solve for d, what would be the last step? Would be to take the square root. So if we take the square root of the whole thing, now, absolute value, do I really need that if I'm squaring it? I don't. When I square it, it's going to make it positive anyways. So to simplify the formula, we put it in parentheses, okay? And we do, I'm going to switch it around. Like slope, they start with x2, so I'm going to do the same, although the order doesn't really matter. Okay, plus y1 or y2, oops, minus y1 squared. Okay, so there you have the distance formula. You see it right here. Okay, I'd write that down. Okay, distance formula is equal to x2 minus x1 squared plus y2 minus y1 squared. Having that distance formula, we can just simply plug the numbers in and solve it without having to graph it. And they may give you really large coordinates that are impossible to graph because they're off the grid. All right, so we would, in those cases, we would really need to use this distance formula. You can graph it, but this just shows you an easier way to do it. All right, so here we go. We've got 2 points, 3, -2, and 6, 4. Now I could draw the Pythagorean theorem with this. We look at this. This one's in between a little bit, so that would be kind of hard to do. Or I can just use this distance formula that we created from the Pythagorean theorem. All right, so there it is. Distance is equal to x2 minus x1 squared. We already mentioned this. All right, now, what are we going to do to solve this? Okay, just simply subtract your x's. 3 minus 6, or if you like working with positive 6 minus 3, like I said, the order doesn't matter since we're squaring it. And then we're going to take 4 minus a -2. Okay? So we see there we just plug it in. Subtract your x's to get the distance of x. Okay? We do put this in parentheses, and then 4 minus a -2. It's going to be real important to be careful with your negatives. It's easy to mess up the negatives. So when I'm subtracting a negative, make sure that we change that to a positive. Want to do inside the parentheses first. Okay, 6 minus 3 is 3. 4 minus a -2 is 6. Then we'll square them. We get 9 plus 36. Add that under the radical, we get square root of 45. Okay? Square root of 45, we could simplify, or we could find that as a decimal. Right now, we're just learning about how to solve the distance formula. All right, the midpoint. Okay, the midpoint of a line segment is a point that divides a segment into 2 equal lengths. We look right here. There's the middle of the 2. All right? Now, we think about the middle. If you just think about on a number line, all right, if you have x values, if you think about on a number line, you've got from 3, let's say, to 7. What's in between those 2 numbers? Well, I could think of it out logically. If I add 2, I would get 5. If I subtract 2, I would get 5. 5's in the middle. Now, another way you think about middle, you think about average, you think about mean. Okay, the average of the 2 numbers will give us the midpoint, or the middle of the 2. So 7 plus 3 is 10 divided by 2 is 5. Okay, so this is what we're going to do when we have coordinates, the same thing. If I want to find the middle of my 2 x coordinates, I'm going to add them and divide by 2. If I want to find the middle of my y coordinate, I'm going to add it and divide it by 2. There's a formula right there. x1 plus x2 divided by 2, y1 plus y2 divided by 2. All right, let's go ahead and pull these up. Okay. All right, so we see there we get 3 plus 7 divided by 2, 5 plus a -2 divided by 2. We want to be careful with your negatives. It's easy to forget this one and subtract, but if you can think average, it'll help you remember to add these and not subtract. Okay? All right, put this up. We've got that blocking it a little bit. Let's try to erase all that. There we go. Okay, 3 plus 7 divided by 2 is 5. 5 plus -2 is 3 divided by 2. I can keep that as a fraction, 3 over 2, or I can write that as a decimal, 1.5. Either way is fine. All right, example number 5. Okay, coordinate plane can be used to model position of players on a football field. So we have where these two players are. Okay, you've got your quarterback and your receiver. The quarterback is on the 30-yard line. Its coordinates then would be 30, 10. Okay, we see here that he's on the 30-yard line and he's 10 yards from the sidelines there. You've got the receiver who is on the 50-yard line and he's 40 yards away from the sidelines as well. Okay, find the length of the pass as a radical and simplest form. So we're keeping this one there specific about this. Then using calculator to estimate the length to the nearest yard. So we're going to find it simplified as a radical, and then we're also going to find it as a decimal. All right, so once again, we're going to use our distance formula. Plug those in. X values, 50 and 30. 50 minus 30, that'll give us our X. 40 minus 10, that'll give us our Y. So we're going to plug those in just like that. Okay, subtract inside the parentheses first. 50 minus 30 is 20, and then we're going to square it. 40 minus 10 is 30, then we're going to square it. All right, let's go to the other side of the screen. All right, we get 400 plus 900. All right, distance is equal to the square root of 1300. Okay, if I simplify that, okay, and actually I think I put this into my calculator, 1300, take that square root, is approximately 36. They did want us to simplify the radical. Now, 1300 is the same as, we can take out radical 100 times radical 13. Okay, if we do that, we know that square root of 100 is 10, and so this would be equivalent to 10 times radical 13. They wanted both answers there, so we get 36 and we get 10 radical 13. Okay, that's the distance formula. Very applicable. We can use this in many scenarios to figure out distance. I remember Pythagorean theorem is pretty cool. Jesus very well could have used that in his carpentry when he did his carpentry. Now, the question is, did he have to learn it, or did he already know it? We don't know, but it is an interesting fact to think about. All right, if you got some comments or you want to comment on what you think, I'd love to hear from. All right, talk to you later. Bye.